Let's get back to the map of our models. We've so far built 3 different models and used several different validation metrics, including ROC curves, to choose the model that performs best. We could end our investigation here. However, we can ask a further question. Will changing the classes change the model? Let's investigate this a little bit further. To investigate this question a little bit further, we come back to our original point where we started building our models. To continue that investigation, we'll now build new classifiers by redefining the classes. Then we'll use different validation metrics and choose a new model. At this point, we have our entire map of our model building and validation process. Let's investigate this end a little bit more to see what metrics we can use to validate models with our new classes. We are back to the Precision, Recall, and F-score video 28. The sensitivity and specificity of a classifier are symmetric measurements in the sense that the changes in false positives or false negatives do not affect the sensitivity or specificity respectively. Thus, in our example, we had 2 instances of classes, B and F, and we decided, thus in our example, we had 2 classes, B and F, and we classified between those 2. Now we re-ask the question to see if we can choose between 2 classes that are asymmetric. In our new problem, we have slightly redefined the problem. We want to ask if something belongs to class G or not class G. This is a one versus all classifier. We're going to look at some metrics called precision, recall, and F-score that helps us in validating classification problems and models based on these kind of classifiers. The difference being the instances for class G are a lot less than the instances for not class G in the data. Let's get back to our IPython notebook and see how we can build these models first. In this piece of code, we are starting to classify person 1 versus all. We call that OVA person or one versus all person, and we chose G as that class. We now divide up the events such that we have G and not G as the 2 classes. Let's run this piece of code first. In the previous piece of code, we have set up the one versus all data. Let's look at what the Y values are between the indices 220 to 230. Run this piece of code now. You see the 10 values are F's and G's, with the last 4 values being G. Now let's see how this looks when we have the one versus all. Let's see how this looks for the one versus all data. Run this line of code. Notice all the labels that are not G are labeled as false. All the labels that are G are labeled as true. Running the next line of code gives you the total number of false and true in each of the training and the test samples. We are now ready to build our models. Run this line of code that initializes the models and trains with xtrain and ytrain with the one versus all model. Now that we have built our one versus all models, let's try to print our accuracy or score for each of these models. Running this line gives us the accuracy for each of the logistic regression, random forest, and support vector classifier models. Note, this time the classes are quite different than what we had before. Now we will define a few more metrics that are useful for selecting between these kind of classification models. We are now going to look at the definitions of precision, recall, and F-score, and come back and calculate these for the model we just built.